Hey guys, welcome to this session by Intellipaat. And in this session, we're going to look into a DevOps tool called SonarQube. So SonarQube is a continuous inspection tool which can be used to test the quality of your code. So now in this session, we're going to look into SonarQube comprehensively. Now before moving on to this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now let's take a quick glance at the agenda. So we'll start off by understanding what is software testing, and then we'll be looking into dynamic and static testing. Once that is done, we'll understand static code analysis, and after that we'll start off with SonarQube. First we'll understand what is SonarQube and then look into the features of SonarQube. And finally we'll be looking into the installation of SonarQube. So now without any further ado, let's begin with this session.
What is software testing? Software testing is a part of software development lifecycle. Its aim is to ensure that the code to be deployed is of high quality with no bugs and no logical error. If you imagine yourself as a developer making an app in a company, then your job would be to develop the code. But then after it's done being developed, it's sent to a tester who makes sure that the code is of high quality with no bugs and no logical errors. He does so by running rigorous tests on that application to make sure it's a proper application. And if there are no errors in the tests that are found on the application code, then it's sent for deployment. And if there are errors found, then the tester sends it back to the developer so that the developer can fix those errors. And then the cycle repeats until a proper application is developed. Now, why do we do software testing? Software testing is very important while making software because we need to make sure that the software is of high quality. Only then will we be able to have customers that are loyal to us, customers that are comfortable using our product. For this particular reason, 30% of the time for software development is given for testing. It is necessary that the customer must be satisfied, and it is also important to have high quality applications so that we can make sure that the customers solely and comfortably use only our products. Testing also decreases maintenance costs as it increases the quality of the code, so that in future, if we hadn't tested our code properly, then an error might have appeared, and then we would have to go and solve the whole error, and it will take time to rework it. Instead of doing that, if we had tested it earlier, we wouldn't have to spend so much money and time on it. And that way, software testing decreases the time and cost it takes to develop a software. Software testing also helps in ensuring that the code that is produced is secure and safe. Now let's see the software testing classifications. There's testing type, in which there's manual testing and automatic testing. Manual testing is self-explanatory. In manual testing, the tester tests all the test cases by himself. He writes them and then he tests them on the code. But in automatic testing, the tester just writes scripts that are standardized tests that are run on the application. And then testing methods. There's static method and there's dynamic method. And testing approaches. There's the black box testing approach, white box testing approach, and gray box testing approach. In black box testing approach, the tester doesn't know the internal structure of what the application he is testing. In white box testing, the tester does know the internal structure of the application he's testing. But in gray box, it's kind of mixed. He knows a little bit, but not that much. Hence, a gray box device is an application whose internal structure is known somewhat. Then there are testing levels. There's unit testing, in which each module is tested separately. Then there's integration testing, in which a set of modules, when integrated, are tested. And then there's system testing, in which the whole system as together is tested. And then there's acceptance testing, in which the whole system is tested for acceptability, whether it fits the requirements of the client's or the customer's needs. Static testing. It is a method of debugging by examining the source code before a program is run. That is, the test code without actually executing it. It does so by analyzing the code against a preset of coding rules and ensures that it conforms to the guidelines. What happens is that the developer writes the code, and while he is writing a code, a static testing tool reads through the code and then it analyzes the code. And after it's done analyzing it, if there is an error found, then it informs the developer about it, so that the developer can fix it right there and there itself. Now, static code analysis. There are many tools which help in static testing and provide us with an analysis for better comprehension. Like I said before, what static testing tool does is it takes the code while it's being written and then performs an analysis on it. If we took an example of SonarQube, what happens is that while the developer is writing the code, SonarQube goes through the code, and based on a set of rules that are already predefined, it sees whether the standards of the testing are performed or not. Suppose in my team, in my developing team, we have some standards that are set by the team lead. If we want to make sure that these standards are met, we use a static testing tool, which will then, in the end, after all of the code is written, give a comprehensive analysis to the developer, who can then read it and then accordingly make changes to his code. This testing only happens during the development. In dynamic testing, the testing happened during the execution. Static testing is an early testing, which is not exactly done by the testers and is done by a static testing tool. Your normal IDEs can do it too, but a tool like SonarQube does it in a much more comprehensible way, and it has many features that we can exploit. Now let's see what are the reasons to use static code analysis. The first reason, finds errors earlier in development. It basically helps us find errors way earlier in development before the product even goes into production. And because of that, it becomes more cheap and easy to fix them. Now, instead of fixing an error that has been way down the production line, we can just fix it early on and not cause a lot of money and time to be wasted on it. Detects over complexity in code. It helps detect if the code is written in a very complicated manner, even though it can be written very easily. Now, sometimes we as developers think that we should write something in a much more complex way because it entices us. But SonarQube or another static code analysis tool will identify that the code has been written in a more complex method and will suggest a more simpler method for it. Now, it's not always necessary that the developer wishes to write the complex method. It could be the reason that he doesn't know how to write the simplified method for it. Even in that case, the static code analysis tool will suggest a more simplified method to write the same code. Finds security errors. It helps pick up security errors, which basically means it helps the source code be more secure when it is deployed. Whenever the developer is writing the code, the tool helps us understand whether there are any security issues with the code we're writing. Like, for example, if we have written a password and a username inside the code in the text format, the tool can understand this. It helps pick up security errors, which basically means it helps the source code be more secure when it is deployed. Whenever we're writing the code, there's a chance that we might write the username and the password in the code instead of injecting them into the code. So the static code analysis tool will identify this and will tell us about it so that we can fix our mistake. Enforces best coding practices. Developers may forget to follow best practices specific to a coding language. It can help solving in that issue. So what happens is sometimes developers do not follow best practices that are specific to a code language. Suppose you're writing C++ and there are some standardized practices that have to be followed when writing C++, but the developer doesn't follow them. So the tool will identify that and report it as an issue so that we can fix it. Automated and integrates in Jenkins. It can be a waste of time to regularly ask the testing software to test the code. Therefore, to solve such a problem, we integrate the static testing tool with Jenkins. Now, when you're writing a code, it could be very annoying to keep on clicking on test the code. To solve such issue, what we do is we integrate our software static testing analysis tool inside Jenkins so that we don't have to click on test our code again and again. It will do it by itself. Can create project-specific rules. They allow us to write project-specific rules. We can customize these rules for each specific project too. When we work in a company or when we're working with a team, our team lead tells us that there are some specific rules we have to follow for this project. We can configure these specific rules using our tool. Whenever the developer or we are writing the code, the tool will identify whether we're following these rules or not. If we aren't, then it will raise it as an issue. And we can customize these rules specifically for each project also. For different projects, there can be different kinds of rules that the team or the company wants us to apply. Some examples of static testing tools are SonarQube, the one we're going to learn, Coverity, and PyCharm. Now let us try to understand what technical depth is. It can help us in solving issues that are related to software testing. Technical depth directly translates as the implied cost for additional rework that can occur if at an early stage an easy but not an efficient solution is chosen. In future, the easy code may restrict scalability. Now imagine you're a developer and you write a code with a complex solution to a problem, and then you send it for deployment. You can do this in two ways. You can either write an easy solution or a complex solution and then send them for deployment. But there's a chance that the complex solution that you've written after some time can allow for easy expansion. But the easy solution that you found early would not allow the same. In better terms, if I gave an example to you, if I was working in a company as a developer and I thought that this problem, a problem that occurred, has two kinds of solutions, a complex solution and an easy solution. Now I go for the easy solution because it costs me less time to write the easy solution because it's easy instead of writing the complex solution that will take time. After I write the easy solution, it goes for deployment and it successfully deploys. But in future, when the company wants to scale, this easy solution that I took earlier will not allow them to scale. It will cause errors. It will need rework. So then more time and energy will be spent and even more cost will be spent to fix that issue. This is what technical debt basically means. It's the debt we imply on our company when we choose an easy solution instead of going for the complex solution. It's a debt that will cause errors later. The more debt we collect, the more amount of costs for additional rework we'll need to spend in future. A static code analysis tool can also identify how much amount of technical debt a person is acquiring when he writes his code. Now let's see what SonarQube is. As you may have already guessed, SonarQube is the static analysis code tool. It basically goes through a developer's code and identifies errors at an early stage. It's an open source static testing analysis software. It is used by developers to manage source code quality and consistency. Some of the code quality checks are potential bugs, code defects to design inefficiencies, code duplication, lack of test coverage, excess complexity. Potential bugs is easy to understand. Code defects to design inefficiencies basically means that when we write a code and it's not very design specific or it's not very compatible with the design or the structure of the application we're going with, then it can cause a lot of inefficiencies. Code duplication. Code duplication takes a lot of memory. To resolve that, the tool helps us. Lack of test coverage, which means that sometimes there aren't enough tests written for a specific code. Excess complexity. Like I said earlier, SonarQube can identify sometimes a solution that is written in a much more complex way and then suggest an easier solution for it. Now let's discuss what are the features of SonarQube. It can work with 25 different languages. As you can see the examples given here, it can work with Java, .NET, JS, Cobol, PHP, Python, C++, Ruby, Kotlin, and Scala. One of the features of SonarQube is to identify tricky issues, and there can be many different types of tricky issues, and we will go through them here. Detect bugs. SonarQube can detect tricky bugs or can raise issues on the pieces of code that it thinks is faulty. It basically means that sometimes that bugs that the coder can't understand early can be identified using SonarQube. Code smells. Code smells are the characteristics of a code that indicates that there might be a problem caused by the code in future. But smells aren't necessarily bad. Sometimes they are how a functionality works and there is nothing that can be done about it. This means that sometimes when we write code, it can mean that we do not use the best practices or we do not keep the best practices in our mind when we write the code. And this may cause problems in future. It's kind of like technical debt. If we don't write the code properly, then we might have future problems, errors that may come in future. But code smells aren't always a problem. They're sometimes the only way we can write a code, and they're sometimes the only thing we can do, and there's nothing we can do about it. Security vulnerability. SonarQube can detect security issues that code may face. If a developer forgets to close an OpenSQL database, or if important details like username and passwords have been directly written in the code, then SonarQube can identify these things. Because Leaving an SQL database open can cause issues in the source code. And you definitely do not want to write the username and password directly into the code. You would want to inject them, because if the website or if the application is hacked, then the other person that is hacking the application can figure out these details and then access into more company applications and cause a lot of damage. To solve this, SonarQube can identify these errors or these issues early in development when the coder is writing the code. Activate rules needed. You can create and maintain different sets of rules that are specific to particular projects. These are known as quality profiles. This basically means that when, like I said earlier, if a person or if the team has some standard rules that it wants to follow, or some specific rules specific to different projects or specific to a particular project that it wants to enforce, then it can create that as a quality profile in SonarQube. And when the developer is writing a code in future, these quality profiles will be tested against the code that he's written. In case if he is not following these quality profiles, then the SonarQube will inform him about it. Execution path. Whenever there is data flow in your program, and there's a lot of involvement between the different modules, SonarQube can figure out if there are any tricky bugs in these execution paths. Now, when a company works on an application, they'll obviously have a code pipeline, a data flow in the program. SonarQube, when it gets integrated with Jenkins or any deployment tool, it works by itself. It keeps on looking for errors by itself. Sometimes SonarQube can figure out tricky bugs that are in these pathways. Suppose an error that depends on a module that is way back in the code pipeline or way back in the data flow in the program, then it can figure out the integration error that happens between these. Another feature of SonarQube is enhanced workflow, ensuring better CI/CD. Automated code analysis keeps working in the background from the development phase itself and monitoring and identifying errors. So SonarQube can be automated by integrating it with a deployment tool or an integration tool, and it'll keep on working by itself in the background, identifying all the errors, the code smells, technical debt by itself, and basically monitoring the health of the program. Get access through webhooks and API. To initiate tests, we do not need to come to SonarQube directly. We can do that through an API call. If you do not want to install SonarQube directly, you can use an API or a webhook to call it and test your program with it. Integrate GitHub. It can be directly integrated with your choice of version control system, which is mostly going to be GitHub. SonarQube can be integrated with the GitHub, and then it can find errors in the version of the code you're using or the code you're developing. Analyze branches and decorate pull requests. It gives us a branch level analysis. That is, it doesn't just analyze the master branch, it also analyzes the other branches, identifying any errors with it. So suppose you have a master branch with a lot of feature branches, then it can identify related errors or any errors in either of the branches. Now the last classification of features of SonarQube, that is built-in methodology. Discover memory leaks. It can show the memory leak in your application if the application has a tendency to fail or go out of memory. This generally will happen slowly over a period of time. Good visualizer. It has a good way of visualizing. It gives simple overviews of the overall health of the code. Now, after the coder has been developing the code for some time, a proper report of how the code is being performing can be created by the SonarQube, and it will be presented on the dashboard so the team lead or the developer himself can go through it, which will tell him all about the number of bugs he has, the number of technical debt days he has, the number of code smells or any security issues that are there. It will let him know about it. Enforces a quality gate. It can enforce a quality gate. You can tell SonarQube based on your requirements and practices what code is wrong and what is correct. Like I said earlier, with quality profiles, you can have quality gates in which you can tell SonarQube based on what all your requirements are there, based on the features, and based on what kind of practices your team follows or your company follows, you can tell SonarQube which code is wrong and which is correct. It doesn't necessarily have to be the standard basic practices or standard rules. It can be the ones that you have developed on your own. Digs into issues. If it shows that there is a problem, SonarQube allows you to go and directly check it out from the summary report or from one code file to another. Now, when you're going through the summary in the SonarQube dashboard, and if you see an error, you can just click on it and it will directly take you to where the code is, and it will give a brief summary of what the problem is in that code. Plugins for IDEs. It has a plugin called Sonar Lint, which helps SonarQube to integrate itself with an IDE, which means there is no need to install the whole SonarQube package. Now, if you're working with some kind of IDE, then you don't need to necessarily install SonarQube separately. You can just install its plugin, that is Sonar Lint, and it will perform all the same things.
Okay guys, a quick info, if you're looking for an end-to-end training in DevOps, Intellipaat provides that, and you can check those details in the description box below. Now let's continue with this session.
Now that we've understood what SonarQube is and why do we need to use it, we can move on and learn how to install SonarQube and then have some hands-on practice with it. Now let's see which all steps we have to take to install SonarQube. First, we will install Docker, and then using Docker, we will pull this latest SonarQube image. We'll be using this method since it's much easier to do it and it gives you a little bit of practice with Docker also. And then we will set up the SonarQube on the browser. And then we will download a sample code and analyze it using SonarQube. But that's a part of the hands-on. Now let's move on. See what are steps we have to take to install Docker. First, we will start our instance. Now, after you log in into your Amazon AWS console, go over here, click on Launch Instance. Then go to the AWS Marketplace and type CentOS. Click on the first one, select that CentOS 7. Continue. We'll be using t2.medium since our requirement needs at least 2 GB of RAM. Configure, add a storage. Okay, let's add a security rule. All TCP, source, anywhere. Review and launch. So after you're done configuring your security details, you can go ahead and click on launch. It will ask you for selecting your key pair, which you can go and create a new one if you don't have one, or you can proceed with choosing an existing one. Since I already have one, I'm going to choose that one, and I'm going to click on acknowledge and launch instance. Then just scroll down and view your instances, and the one that you have created will be at the top. Click on that and copy its IP address. We'll wait for it to get initialized and started before we open the instance. Now to use this instance, we'll have to use a tool called Putty tool, or you can SSH into it. Since this is easier for me, I'll just use the Putty tool. Browse, put my key in. Now if your instance is ready, if it's running, you can go ahead and launch it. Click on yes and log in as CentOS. Now let's make this a little more visible for you guys. We'll go on settings, colors, okay, apply, clear. Wait, let's increase the font size also. 14, 16. This is much more visible for you guys. Let's take a quick look on how we have to install our Docker. Since we are using CentOS, the method of installing Docker is a bit different. Okay, for this we have to go to the website and we have to go to the Docker website. Docker, after docker.com. Now, to get the Docker we need, we will click on Explore, and in Explore, we will click on Docker EE and scroll down, and this is the one we need, Docker Enterprise CentOS. Click on that and start your 1 month free trial. This is just for us getting acquainted with Docker Enterprise. Since I've already downloaded it before, I'll have to come over here and click on my content and click on setup and find this link. Now if you're downloading it for the first time, in that page itself you can find this link, and if you can't, just come over to your username, click on my content and setup, and in that you'll find this link. All right, copy that link and then paste it, and after you paste it, click on 7 over here, come back, click on 8664 and click on stable 18.09 and then packages, And we need 3 files out of here. We will need this file, container.io. We will need docker EE 18.09, and we will need docker EE CLI 18.09. Let's take them one by one. Right click, copy the link address of the latest version, come to your instance, type, let's go into the root. We are inside the root now. We're accessing it as a root. Then use wget command and paste the copied link. Press enter. Okay, we do not have wget in this. If you do not have wget, type pm install wget. Now we use wget to get links that we need. So we'll use the command wget and right click. This will paste our link and press enter. And as you can see, it's downloading the file VLS. We can see that it's been downloaded. Now let's do the same thing for the other 2 files too. Come down, click on the latest version, right click it, copy the link address, use the wget command, paste the link, press enter. Let's copy the 3rd file's link address by the time this gets done. Wget, paste the link, press enter. If we press ls, we can see all the 3 files that we need are downloaded. Now let's go ahead and install them. We'll use yum install container ID. I'm going to paste this here, give space, give space. Okay, I'm going to press enter and install these packages. Yes. This will install your Docker file for you. And once that's done, let's make sure that we have installed our Docker properly. So we'll use the systemctl command, systemctl status docker. This shows that docker.service is loaded, but it's inactive. So let's make it active. Systemctl start docker. This should start Docker. And let's check its status again. Systemctl status Docker. And as you can see, Docker is now active. Let's clear the screen. Now that we have Docker installed and active, let's see what our next step will be. Our next step will be to pull the SonarQube image from using Docker. We'll type docker pull SonarQube latest. This will download the SonarQube, the latest SonarQube image from the remote repository. Okay, now that we've installed the image, let's just make sure we have installed it, Docker images. And yes, we have installed the SonarQube image. Now let's start the Docker SonarQube image. Docker container run -d. Name will be SonarQube itself. Then we'll put the port number as 9000. And the name of the image is SonarQube latest. Let's use docker ps to see if our SonarQube is running as a container. And as we can see, our SonarQube is running at the port 9000. Access SonarQube, we'll have to go back to the browser and type, we'll have to take the IP address of the instance we're using, since that's where we started the Docker container. Paste it and type semicolon 9000, the port address, and press enter. If you've done everything correctly, your SonarQube should be running properly right now. Now we have completed our installation of SonarQube. Let's move on to the hands-on. So let's see what are the steps we have to follow. So guys, in the video, we'll be following a few steps. These are the steps. First, we will install Git and clone the sample project from the given link. Second, we will install Java and Maven. Third, we will configure sonar.properties and connect Maven to SonarQube. And fourth, we will compile and build the sample file using Sonar code from browser. Now let's go ahead with the first step. Install Git and clone the sample project from the given link. So first we'll install Git in our instance, and then we'll download a sample project. Now we'll need this sample project to see how SonarQube works. Let's start by installing Git. We'll head on to our instance and we'll type yum install Git. Enter. Press yes. Now we have Git installed. Clear the screen. We'll come back to the PowerPoint. Copy the link of the project. This is the sample project we'll be using. It's a web app. So let's clone it. Come back to our instance. Use the git clone command. Paste the address of the repository and press enter. As we can see that Git is now cloning the repository into our instance so that we can use it. Now that we've cloned our repository, VLS, we can check that. We have seed pet clinic, we'll cd into it. So we have cloned our repository. Now we'll come back to this later. We'll head on to the website and see how to set up our SonarQube. We'll log in. The default login username and password is admin for both of them. Press enter. It will log in for you. Click on create new project. Project key can be anything. We'll write sample, move ahead, set it up, generate a token also. Anything can be it. The token is used to identify you when an analysis is performed. If it has been compromised, you can revoke it at any point of your time in your code, in your user account. Let's generate it. Now we have this code. We will store it for later. We'll copy this and we'll continue. What is your project's main language? You can choose which is the main language you'll be using. Since I'll be using Java, I'll click on Java. And you're developing primarily in Java. What is your building technology? Since there are many build tools, you can decide which one you want to use. I'll be using Maven, so I'll click on Maven. Execute the scanner for the Maven from your computer. We'll be using this command to execute our project. For that, we'll need Maven too. Now that we've installed Git and cloned the sample project from the given link, we can go ahead with the second step, that is installing Java and Maven. Now, why do we need to install Java? We need to install Java because Java is a dependency for Maven, and therefore we'll be installing Java. And then we will go ahead and install Maven. Maven is important here because when we are using our SonarQube for analysis, we need Maven to first compile the code. We'll be using Maven as the compiler and we'll be using SonarQube to analyze. So let's go ahead with it. Let's go ahead and install Maven. Remember how to install Maven. You have to go to the website, click on download, copy the link of the Apache Maven 3.6.2 file, copy the link address, come back here, cd into opt, and use the wget command, paste the link of our file, press enter. As we can see, it's been installed, and since it's a file that comes installed already, we do not have to go ahead and install it again. We just have to untar the file. The command I'll be using is *zxf Apache Maven, center, and then we have our Apache Maven folder. We'll cd into it. We'll cd into the bin and see if it's working. So for Maven, we need Java. So to install Java, we'll be using the command yum install Java 1.8.0 OpenJDK Devil. Yes, please. Now that we've installed Java, we can go ahead and see if our Maven is working properly or not. Yes, it is working properly. Let's clear the screen. Now, before we can go and compile our sample project, we need to make sure that Maven is available to all of the operating system, not just from this specific location. For that, we'll need to use the command export and the environment variable path. We will set the path in such a way that all of the OS will be able to use Maven. $path /opt Maven/bin. Now that we set the environment variable, we can go ahead and try and compile our sample project. cd home center. Here's the screen. Now let's go ahead with the third step, that is to configure sonar.properties and connect Maven to SonarQube. Now let's see how to do this. cd home ls. Since I've already created that file, I don't have to create it. But if suppose you were creating a project and you didn't have this file, then you'll have to create this file, sonarproject.properties. Let's go into it. Sonarproject.properties. And these are the details that'll be entered, like the Sonar project key, the project name, the project version, where the source is, what kind of language you'll be using, and what kind of UTF coding or what kind of source encoding you'll be using. In this case, it's UTF-8. This file is basically used for configuring all the metadata that'll be required. So let's save it and come out. Okay guys, we have now come to our final step. That is to compile and build the sample file using Sonar code from the browser. Now let's go ahead and see how to do this. Now we will go ahead and compile our project. mv compile is the command used for that. Press enter. Compile the project and the build is successful. And now let's go ahead and use the command that SonarQube told us to use. That is this command after you've set all these details. For running the SonarQube analysis, we'll be using this command. Copy it from here, paste it. Now SonarQube is analyzing the files. Now that SonarQube has analyzed the files, we can go ahead and look at our SonarQube in the browser. Sample project. And after you click on the sample project, it gives you an overview of the health of the project. We have 140 bugs. We have 12 vulnerabilities, 0 security hotspots. We have 2 days of technical debt, and we have 231 code smells and 63.4% duplication. Now it shows us the percentage of code that is being used. CSS 8.1, JavaScript 46K, the lines of code. And we can go and check many things using SonarQube. We can look into the issues directly. As we can see, remove the unused import or .shoda.time.datetime. This is violating a rule, and this is a code smell. So if you want to go and fix it, we can directly click on it and it will dig into the issue. Like we talked about earlier, it will dig into that issue and we will come over to where the code is and we will see the error, the code smell that is over here. Like how we checked out this code smell, we can go back and check any kind of thing we want, any kind of issue. Under the type, we can check the number, the bugs we have, the number of bugs over here, the vulnerabilities we have, the code smells, and it tells us whether it's minor or major. And we can go ahead and check the measures. This will give us a graphical representation of all the things we've done, of all the analysis that's been done on the sample project. Overview of the reliability, how reliable the code is, security, overall security of it, maintainability, and etc. Like coverage, duplication, size, complexity, and issues. We can go ahead and check the code out directly from here itself. We can click on the pom.xml file that will open. And we can check the activity. This is where all the historical data will be stored, like which all versions did we use, and what are the issues that were solved, and etc. And under administration, we can set our quality profiles, the one we want to use, default Sonar way, or we can go and create our own quality gates based on what we want. Here we can set whichever quality gate we want to use, but if we want to create those quality profiles, we have to go over here. Here we can choose whichever quality profile we want to choose for whichever language we want to choose, and we can go to quality gate and create our own quality gate if you want. using this. And that's all for SonarQube. And if you click on projects, it will show you a list of projects over here. Since we have only one project, this is the only project it's talking about. And it shows the overall health over here. So it's a good administratable tool which can be used by integrating to Jenkins or any other deployment tool. Now that's all for SonarQube.
Okay guys, a quick info, if you're looking for an end-to-end training in DevOps, Intellipaat provides that, and you can check those details in the description box below. Okay guys, that's it for this session. I hope you understood and also it was helpful and informative. If you have any queries, leave a comment down below and we'll love to help you out. Thank you.